So one common mechanism by which two-factor authentication might be implemented is via what we call a hardware token. So in this video, I'll talk more about how these hardware token-based two-factor authentication schemes might work. And what I'll do is maybe describe something that's a bit more generic in nature, maybe a more general approach. And I suspect that most of the implementations you see in practice are going to be variations on this general approach, with some of the details perhaps differing. And the reason for that is I want to keep things relatively simple. So maybe, in fact, even before that, I'll try to describe the scheme in the simplest possible way. And I want to stress here that the way I describe it won't exactly be how it's implemented in practice, but it'll at least convey, I think, some of the key ideas and key points. And then afterwards, maybe in subsequent videos, once you have the key idea understood or reasonably well understood, I can talk about some extensions and improvements that perhaps maybe better resemble or better mirror what people are actually doing in practice when they implement hardware token-based two-factor authentication schemes. So let's say you have a hardware token, and let's say this is the hardware token right here, and I'm going to kind of draw it out. Okay, and it's a three-dimensional, but it's a pretty small or typically a very thin token. Okay, and let's say this token belongs to a person, and let's say his name is Joe. Okay, and so this is going to be Joe's token, and this I'm just calling it Joe's token because it's going to be easier to refer to the token that way. Okay, and typically the token will have a display on it. So imagine you've got a display on Joe's token out here. Okay, this might be some type of an LED display or something along those lines. Okay, and in addition to the display, inside of the token there'll be some values. So for example, there may be, actually there will be, I shouldn't say there may be, there will be a secret key value, a secret key. Okay. And we'll call this key value, we'll call it K to keep things simple. Okay, in addition to the secret key K, you will often have in these tokens, you'll have a clock. Okay, and the clock will produce a time, which we'll call T. Okay, and by the way, when I say a clock, this is not necessarily a very detailed clock. It's a very simple clock. It maybe computes time to the nearest minute. And that's actually done to avoid things like clock skew and so on and so forth. And so we don't need a clock that can take time to the second or even millisecond or microsecond, anything of that nature. Okay? And then finally, there will be a very simple computer on this token. And when I say simple computer, I really mean something that can compute a very simple mathematical function. And the mathematical function it's going to compute, we'll call that function h. Okay, for reasons that hopefully become clearer in about a minute. All right? And what's going to happen is maybe periodically, let's say every 60 seconds or every minute, because this has a 1 minute clock, the computer will display or compute a value, and it's going to display the value on the token. So let's say that the value displays is 1, 2, 4, 8, 1, 6, 3, 2. So that's the value displayed on the token in a particular minute. All right. And then the question is, what's the actual value? How is that value computed? Well, again, it's going to be computed using some function h, and h is going to be a function of the key k, and it's going to be a function of the time t taken to the nearest minute, okay? And that's the value that's going to be then displayed on the actual display itself, all right? And what we do need is we need this function to be, it can't just be any old function, it's going to have to be what we call an unpredictable function, unpredictable. And by that I mean that unless you know the secret key k, it should be very hard to figure out the output of this function. In other words, if you just see some outputs of this function at different times t, unless you know the secret key k, you shouldn't be able to figure out the next output value, or really any other future output value, beyond that. And one way you can actually get such a unpredictable function, it turns out you can take something like a cryptographic hash function, a cryptographic hash, okay, and you can truncate the output. And if you saw any of my earlier videos, I made some videos on cryptographic hash functions. You can maybe get a sense for why this kind of approach might work. But in practice, again, you don't need to use a cryptographic hash function, but that's certainly one way you could go about doing things. All right. Now, in addition, let's assume that there's also an authentication server somewhere, and this may be, let's say, that the web server of the bank that Joe is using. So let's say that Joe uses I don't know. Let's say he's got a bank that he goes to, maybe it's a VPN server for his company, and this is obviously a much more massive server. And this server will also know some critical pieces of information. So for example, the server will, let's say it's going to know information about Joe to begin with. So let's incorporate that. So it's going to know Joe's username. Okay. It's going to know Joe's password. Okay. And then in addition to those pieces of information, it's also going to need to know the secret key K. It's going to have a clock that's synchronized with Joe's clock that can compute the current time T. And it's going to have to know that this key K is associated with Joe's identity or with Joe's token. Okay? So now imagine that it is 1:15 p.m. Let's say it's 1:15 p.m. and Joe wants to connect to his bank account at 1:15 p.m. He has to authenticate himself. And let's say he's going to do the normal thing. He's going to request a connection with the server. Okay? And typically what Joe will be asked to do when he initiates a connection with the server is he's going to be asked to enter in his username and password. So he enters his username. And let's say his, username. He's going to enter his password. Let's say his password is Joe, 1111. That's not a very good password, but let's say that's what it is. And then in addition to those two pieces of information, what Joe is going to do is he's going to look at this hardware token that he has. And the hardware token will have on it, it's going to have displayed on it a series of numbers. Okay, and Joe is going to basically enter those numbers in together with his username and password. So let's see, he enters 12481632. All right. Now, the server itself, as I mentioned, is going to have these pieces of information. It's going to have Joe's username and password, the key K, and it's going to know the current time T to the nearest minute. Okay. The server is going to basically then compute. It's going to actually first check that Joe's username and password combination are correct. And the way this is done is going to be somewhat orthogonal to the rest of the scheme. Let's use a standard way of it's going to retrieve the password, check it. You could do more fancy things like cryptographic hashing of the passwords. That's something I would recommend baseline. And I've actually done some other videos which talk about how passwords can be checked using cryptographic hashing. So you can look at those videos as well. But assume there's some way to check the username and password, and certainly if those don't match or if there's an issue there, it's going to be game over for Joe, and he won't be allowed access to any more resources. All right? Now assume the passwords do match. Then what the server is going to do is it's going to compute the hash. It's going to basically say, well, I know it's going to take H, it's going to take the key K, and the time, which is, let's say, 1:15 p.m. Okay? And it's going to then compute the hash value, and presumably, if we're dealing with a deterministic hash function, and if everything was hunky-dory, you would get the value. It comes out being 12481632. All right? Now, obviously, if the values don't match, okay, then that's a sign that something went awry, and Joe will not be allowed any further access. Okay? And if the values do match, then Joe will be allowed access. Okay, the idea here, the real premise, is that without knowledge of the secret key, it would have been highly, highly unlikely for someone to have come up with the correct value. Okay, and that's because we're talking about an implementation that uses these unpredictable hash functions or unpredictable functions. All right? And in that case, that means that whoever did enter, that implies that whoever did enter the correct token value must in turn have possessed the secret key, the key K. All right? And moreover, let's assume that Joe's hardware token was reasonably tamper-proof, and in that case, it would be highly unlikely that whoever supplied the correct value, or I should say it would be highly likely that whoever supplied the correct value actually possesses that token. And assuming the token was in Joe's possession, that implies that it was indeed Joe who entered that value in. So in other words, if you kind of follow this chain of logic, entering the correct value is proof of possession of the hardware token. In other words, you've satisfied the kind of something you have criteria for authentication. You have the something you have, which is that hardware token, okay? Moreover, in this scheme, we also had Joe enter his password. And so then we satisfy the something you know criteria. The password satisfied that criteria. Okay, so we have something you have was satisfied by this token value. The something you know was satisfied by Joe entering his password in. All right? And these are the two of the factors of authentication, and we discussed these factors in the previous video. And so the scheme that I just presented really constitutes a two-factor authentication scheme. And again, as I mentioned in the last video, it's just one way to implement such a scheme. There are many other ways to implement it, but the approach I outlined above and really in this video happens to be among the more well-known ways in which two-factor authentication is implemented.